All right. I think we're live, guys. I think this is it. We're going to be having tons of fun today. It's a little bit shorter of an update just because, we had Thanksgiving and everything. But it is all good. All good. Okay, let me see here. There we go. We are live on X. That's great. It looks like I'm just going to check our liveness in Telegram to make sure that everybody can see it. Let's go Telegram. Okay. It looks like it's live. All good. We are live in the different places. So, Lim, to answer your question, we ended up pushing TGE back to Q1 just because of market conditions. We had a discussion about that last week on the community update. So, happy to respond to that in any more detail. I don't know how much more I can get into that until the markets start to adjust, but we're ready to go. We're locked and loaded. We're already integrated with Metaplex. We already got the tokens ready to go, so we're ready to launch as soon as the markets give us the green light. Lim, I got your. I also got your ticket, so and your address. So I'll be responding to you, or at least having the team respond to you in the ticket in Discord. By the way, if you guys have any issues with anything, like if you are having issues setting up the CLI tool, the actual node software, or you're having issues with tracking your points, just let me know, or just submit a ticket is really the place to do it. You submit a ticket. We have a whole team that's watching those tickets and responding where they can. Sometimes I get involved because it needs me to get involved. So, Lim, we're actually absolutely going to be doing that for you. So, but today, my Discord folks, you're going to be seeing things in reverse here, and that's okay. But I will be sharing anything that's important. I'll be sharing directly into Discord as well as on the stream. So I'm going to go ahead and get the chat showing here as well. So if anybody wants to chat in X or in Telegram, you can post your messages there. It'll show up on stream. But today, kind of the agenda of what we're going to be going through, we've got a robotics demo we've been working on that I want to share some screenshots from. We also have a little bit of the white paper I want to go through, and specifically on the white paper, I want to talk about the architecture of the Tashi network because I think it's so unique and it takes a little bit of time for people to really catch on to. So I want to make sure that everybody understands what the properties are of the Tashi network and the different layers and why they're valuable. We talked a little bit last week about it during the AMA. This week I'm going to go a little bit more structured into it. Very briefly, I'm going to talk about a new CLI tool that we're working on. So I just wanted to get people updated on that. I know if you're using the current installer script or using Docker, you kind of have to know Docker, or you have to be like on the right type of machine with the right operating system for the install script to just like work out of the box. Otherwise, you're kind of finagling things. So we're trying to fix that up a little bit. And then at the end of this, we're going to do a quick little AMA. So okay, so let's go ahead and go real quickly into the updates, and then we'll open it up for AMA at the end. So the first thing I wanted to kind of show off is our robotics demo. So I'm going to have to show this in two places at once. So bear with me as we transition over to That's one thing that's going on. All right, let me hop back here into Discord. We're gonna go ahead and stop the share there. All right, so that's the robotics demo. We can talk more about that a little bit later. I do want to talk a little bit about the white paper because we're so close to being done with it. Let me go ahead and I'll actually share real quick the section. Oh, I might not have been Oh, I might not have been. Oh, I might not have been. Okay, sorry about that, everybody. I didn't have my audio going. Well, on this particular screen, I didn't have the audio going. Okay, sorry about that, everybody. I didn't have my audio going. Well, on this particular screen, I didn't have the audio going. Okay, now I got to figure out where this audio is playing. Okay, sorry about that, everybody. I didn't have my audio going. Well, on this particular screen, I didn't have the audio going. Okay, now I got to figure out where this audio is playing. Okay, sorry about that, everybody. I didn't have my. Gonna have infinite audio going everywhere. Well, on this. Let me just turn the desktop audio off for now because I don't have anybody in chat. So we're gonna turn desktop audio on the restream back. But I now have to figure out where I have the restream coming in. There it is. Okay. I have now dropped out of the video chat in Telegram. Okay. Sorry, guys. This is what it's. Blah, blah, blah. It's all over the place. Yeah, Discord's working great. It was just when I went to the small version of my image in the stream, I didn't have the audio on that scene in OBS. And so it looked like the audio was there, but then when it actually was on the scene and I transitioned to it because I'm in studio mode, I know, trying to be all techie and stuff, I just failed to copy over the correct audio. So sorry, everybody, during the discussion of the demo, you probably weren't getting audio. Oh no, on X. We'll figure this stuff out someday. I mean, this is technology, right? But Discord, again, if you were in Discord, you heard everything. So come join us in Discord for sure. Okay, so back to our discussion about Vertex, right? So we were talking about the difference between how we do this in Tashi, what Vertex is and why it's valuable, versus how blockchain generally does this. So in blockchain, you're usually talking to a smart contract. The smart contract is the arbiter of truth. Every other client synchronizes with that smart contract, but there's going to be a delay in that. I mean, there can be anywhere from a few seconds delay to a few minutes delay, and in real world applications, we can't wait for that. So that's what Vertex is about. Vertex is this layer that basically says, hey, listen, robots should be able to talk to each other directly. And so what we did is, instead of having the consensus protocol living in a blockchain with a smart contract behind it, we're basically saying, what if we were to load the logic, which is the equivalent of a smart contract, on every single robot, right? What if we put that on every single robot? And then they just broadcast messages to each other as if they were their own miniature blockchain that was application specific. And they're validating each other and creating these signed states. So we can actually go back and see that, okay, as long as 2/3 of the participants in this network were honest, we can confirm that all the messages are correct. Now, the beauty of doing it this way is there are a few other properties that come with it. The first property being that usually if you're participating in one of these small Vertex mesh nets, is what we call them, these little mesh networks, if you're participating in a Vertex mesh network, you're interested in the outcome of the network itself, or of the job itself for that network, right? So sorry, the little arrows are driving me crazy a little bit here. And so you're less likely to be malicious. But even if you are, and we randomly connect you, or you connect randomly with other people, it's less likely that people can collude. And if you create large enough Vertex mesh nets, it's a lot less likely that people are going to collude. Our sweet spot is really between 30 and 32 participants in a network, and we can keep that latency nice and low for like sub 100 millisecond latency. I guess that's a great thing to bring up here, is that in this place, we're talking about like less than 100 milliseconds latency, which is crazy fast, because even the fastest L2s we're talking about are going to be like in the 400 millisecond latency space. And then I'll put in here, and these little mesh nets, these are 4 to 32 participants are kind of the sweet spot. But we've gone as high as 100 participants and still gotten incredible latency, meaning that we were in the like 200, 300 millisecond latency with 100 participants participating in one of these networks. But really 4 to 32 is the sub 100 millisecond latency sweet spot, which is great for most workloads. If you can think of most workloads, you're not going to have more than 32 participants, whether they're devices or computers or databases participating in a particular workload. And if you do, you usually can partition those down into smaller mesh nets. And so you can have layers of mesh nets. And so that's where we see this is like this model right here. You could have hundreds of these going on, right? These could be a ton of these different mesh nets happening at the same time in the vertex layer, right? These are all individual, you can think of them as individual blockchains that are job specific. That's the other thing about it is how quickly we spin this up and spin it down. It's like instant up and instant down, right? So there's no spin up time. There's no effort to spin these up. You can load it as fast as you can load a video game. You can load it as fast as it takes your robot to kind of spin up its servos and start operating. So it's not like you're setting up a permanent blockchain somewhere to handle a particular workload job. It's like, no, we're going to incorporate our technology into as a plugin to the SDKs you're already using. So in robotics, where we've got ROS, we will have a module that plugs into ROS, and now you can use ROS like you normally would as part of programming your robots. But now you have the capability of doing this validation and clustering of robots in ROS. We're not telling you to adopt a whole new framework. We're not telling you that you have to manage cryptographic keys or that you have to go talk to a blockchain. We're just saying use ROS, put our plugin, do a little bit of address book management, and boom, you're up and running. If you've ever played with FoxMQ, FoxMQ is a message queue broker we built using the Vertex technology. And it's basically a multi-leader, I shouldn't say multi-leader. I got to be careful about my terms because the word leader means something in blockchain space. Historically, we would call it a multi-master configuration, right? So traditionally, you had the primary and secondary databases or message queue brokers. The primary, you usually had one primary database. That is where you did all your writing. And then you'd have secondary databases that would synchronize with the primary database. And that's where you do all your reading. So if you had a lot of reads against a database, you might set up a primary, secondary configuration where you have one primary database that takes all the writes in and a whole bunch of secondary databases that provide all the reads out, right? But what people really want is they want a multi-primary configuration. It's what we used to call multi-master configuration. And that's effectively what we built with FoxMQ. You can think of FoxMQ, right now this is R here, but really if this was a message broker, and this was a message broker, and this was a message broker, you get where I'm going with this. You now have a multi-primary or multi-master message queue MQTT broker. Same with video games, right? So if this is a player and this is a player, you now have multiplayer, but you have multiple primary servers or multi-server configuration in a multiplayer scenario, right? So Vertex is very versatile. It can be used for all kinds of use cases. This is kind of the heart of what we're building. So I just want to call this out. This gets explained a bit in the white paper, but again, I feel like every week this is a good topic to go over because it's so different than what everybody else is doing. And then we go in and we say, okay, what about the next layer up? This is the DePIN part, right? So lattice is our DePIN, right? So this is the DePIN layer. And why do we have lattice? Well, we have lattice because these Vertex mesh nets need services that they can't provide themselves. And an example of that service is discovery. You know, how do these peers find each other? You have things like identity. You're going to have things that are very network related. So you're going to have things like stun ice, which is, I know ice is a scary word these days. This is your network traversal, right? So this is like, how do we get around things like firewalls and NATs and stuff like that? And then you're going to have things like turn. turn servers. This is what we've been calling our relay or our proxy. So turn servers allow, even if one of these devices is behind a firewall, effectively what happens is instead of this, we'll pick on this one right here, right? Actually, yeah, let's do this one. So for example, if we take this and we just basically go, let me move this down here so that it's easier to do. Nobody directly talks to this one peer because this one peer is unreachable, right? So everybody, in addition to talking to each other, they're also going to talk to this peer via the relay. So if there is something that is blocking, say that there's like, I'm just going to draw a line here and just go, this right here is a firewall. It can't see the other peers in this network. These peers can see each other, but they can't see this one peer. So what ends up happening is, oops, that was wrong color. There we go. I know this is all kind of wonky here. As I start moving things around, this gets wonky. But these peers, these robots are going to talk to each other. But if they can't see this one robot because it's behind a NAT or a firewall or something, they can use the stun ice or the net traversal service to try to get around this firewall. And if they still can't get around it, then they can go use this turn or this relay server to get around it. And so now this participant gets to participate in the mesh net, the Vertex mesh net, even though there's a firewall between it and everybody else. These services can't be facilitated easily by these devices unless these devices have public IP addresses and are also running a turn service or a relay service. It's not easy to do. So this is where you guys come in. This is where DePIN comes in. This is what we call lattice here. The idea that you guys are hosting nodes that are making it possible for these mesh nets to exist. That's the first and primary function of Lattice, is to ensure that if we don't know who each other are and we want to form a group, a mesh net, to solve a problem, we could be doing AI inference. We could have a message queue. We could be a multiplayer game. My robots are working with your robots to do stuff. We've got discovery and identity that has to happen in the first place. So how do we discover each other? How do we communicate with each other? We're going to use stun and ice and turn to get around network blockages so that we can communicate with each other. So when you're running a Tashi node, you're effectively running these services on your machine. And you're saying, hey, anybody who wants to go set up a mesh net, talk to my node and my node will help you set up that mesh net and will ensure that that mesh net is successful. So that's what all of the nodes in the lattice layer are doing. This is what the DePIN itself is doing. It is providing these services into these mesh net configurations. Now, that being said, is this the only value of Lattice, is to support mesh nets? Not necessarily. I think mesh nets are a primary driver, but anybody that needs a turn server, anybody that needs a relay out in the wild could absolutely tie into the Lattice SDK and start accessing the turn service or the stun ice service. If, for example, they wanted to do a browser-to-browser WebRTC communications channel, right? That's going to use stun, ice, and turn. And you're going to be leveraging the decentralized network to provide that service. So while we are driven by mesh nets, that is our forcing function is this vertex layer, also know that in addition to the revenue opportunities that come with the businesses we're going after in the vertex layer, there are additional business opportunities happening in the rest of the world for people who just want to use these services and don't want to pay Google or Amazon or Microsoft for it. They can just reach out to the Lattice layer and access any of these services, ad hoc and use them for their own use cases. So outside of the Vertex meshnet configuration, there's still value for the Lattice DePIN layer. And I think this is what really differentiates us from a lot of other DePINs, is we're not trying to be general compute. We're not trying to be general storage. We're trying to say there are very specific problems that need to be solved in the internet that currently are solved by Cloudflare, Google, Amazon, and they're great services. Sometimes they're not sufficiently low latency for our use cases. So that's why having DePIN services at the edge is valuable. Sometimes they're too expensive, they're cost prohibitive, which is also why the cost of this is so much lower, and there's a huge upside benefit there. But fundamentally, what we're doing is we are creating efficiencies. We're basically saying, right now, all of these services kind of live in either your own data centers or in the cloud. And you're either paying for co-location or you're paying somebody to host them for you. And we're saying, instead of that, why don't you just go out and access a currently latent device, a device that is underutilized or not being utilized. So this is the vertex and lattice layer. So I just want to make that clear. Like, this is how these two things work together. We're focusing a lot on vertex because we think billions of dollars could be saved every year with this type of configuration. And I'm saying that very conservatively. Multiplayer gaming infrastructure, somewhere on the order of $30 to $45 billion a year, is what game developers or game studios are spending on gaming infrastructure. With this configuration, as much as 80% of the network traffic could be pushed off into these multiplayer mesh nets. And network egress is a huge cost. So let's assume that that's maybe 60% of the infrastructure cost, and the server costs are the other 40%. But say the network cost is 60%. What if we could just take 60% of their expenses completely off the table just by shifting the model from a server or cloud-based gaming infrastructure, even a data center-based gaming infrastructure, to a peer-to-peer multi-primary leaderless configuration? So that alone, if you're talking 60% of $30 billion, right? That's a huge amount of money. What is that, like $15 billion that we could be say, wait, 60% would be more, right? Yeah, that 15 billion would be half. 60% is more than that. So $18 billion. So $18 billion that you could be saving in an entire industry. So the opportunity is huge, right? And even if we don't even charge that much, say we're 1/10 the cost, that's a $1.8 billion market. Okay, great. Say we get a 10% market penetration. Cool, that's a $180 million market. Like, these markets are massive. The opportunity to create efficiencies in these various markets is massive. So that's why we're building this. We're building this because we don't believe that like all of the solutions are going to be a blockchain in an L1 or L2 or L3 configuration. It's going to be a more hybrid distributed model where you're going to have services that are going to replace a lot of the cloud services distributed by node operators, and they're going to be leveraging underutilized devices that you already have at home, your computers, your Raspberry Pis, all that stuff. And the actual architecture of the problem space is going to change. So instead of machines or devices or message brokers talking to a server somewhere, they're just going to solve the problem between each other using a consensus protocol with this signed state and validating each other. So using cryptography, we can actually create massive efficiencies. So we're so early on this, though, like people haven't even wrapped their head around this. Okay, now the last layer up here, and I'll be a little bit quick with this one, but this is ARC. And we call this ARC because it is when you think of like an electric arc, it is the electrical connection or the electrical high point between two conductive materials. And so we think of lattice and vertex as one edge of the conductive material, and the other edge of that is going to be the L1s and L2s, right? And so in this space, we're creating plugins that allow you to do things like, let me put this up here, say escrow contracts. So you can lock assets up in the L1 or L2 and load them into these vertex mesh nets. And then you can act on them. You can think of it kind of like a dark pool. You can act on those assets. They create basically a virtual ledger down in this mesh net. They act on it. They validate each other. They create the signed state. And then the signed state gets passed right back up to this escrow contract. Right? So now we can use the escrow contract to load assets, launch into a mesh net, and then settle those assets from the mesh net back into the L1s and L2s. So now we're creating scaling efficiencies for L1s and L2s. So you have assets in blockchain right now. We've got plenty of cryptocurrency. You've got plenty of tokens that are living on public networks. Where we need to have public interaction or public asset attestation, or even public signaling, if we want to use other types of signaling contracts or things on the L1, L2 layer, we can use the ARC layer, which ARC is just a collection of plugins that allow you to tie in various lattice and vertex services into the L1, L2 space. So now we can do all kinds of things, loading and settling of assets, public signaling. So if something happens in a robotic cluster that we want to send a signal up into a smart contract somewhere, maybe we just send a hash of the state of this mesh net up into the smart contract. So we might even just have like, we'll call this an attestation contract, right? Or like in Hedera has the consensus service. So they've got their own HCS, which is kind of like it's almost like a public message queue, right? You can send messages from these signed states up into these attestation contracts and up into these public message queues. And now anybody who's observing these things can act on that. And that might be other contracts that trigger other mesh nets. It might be mesh nets. It might even be listening to those contracts. So you might have one mesh net over here doing a bunch of work, sends up a public a message queue message that then triggers activity in another one of these mesh nets. So this is, you can think of these as almost like plugins into the vertex and lattice layers that integrate nicely or seamlessly with the L1, L2, L3 public blockchain space. And so in this way, what we're really doing is we're adding efficiencies to existing assets. We're adding real world workloads to existing assets. This is so different. And it's hard sometimes to explain this when we're talking to investors or we're talking to early adopters. It sometimes takes a little bit for people to understand what we're doing here. We've basically taken this model right here that is this L1, L2 model that everybody's been trying to operate on in the Web3 space for years. And we're saying, what if we broke that down into multiple layers? What if we created effectively a decentralized cloud in Lattice? And what if we push the majority of the workloads down to the actual participants or the stakeholders who are interested in the outcome of that workload? What if we were to break these problems into smaller parts while still using consensus as the trust model, right? We're still using signed states, cryptography, and a consensus algorithm to ensure that these guys are all watching each other and in sync, and that they're passing these proofs up and down the stack. So we're retaining the trust. If anything, we're actually improving the trust in some cases, but we're at least retaining the trust while creating efficiencies for what has kind of been a relatively inefficient blockchain ecosystem. So we're really kind of coming along and saying, okay, we did a bunch of really good stuff with tokens and with cryptocurrency and smart contracts. We've established some good trust models, but now let's make this usable. Let's break this into multiple layers of problem space and solve this through this kind of 3-layer architecture. Okay, I wanted to bring that up because this is part of the white paper. The Tashi stack is section 3 that talks about this. We're going to be adding some diagrams to kind of help with that. But it talks even more about like, okay, why is there trust at the vertex layer, right? What are the performance characteristics of it? What are the key features of mesh nets being vertex in action? And then what is lattice? So all of these things are going to get captured in the white paper, including ARC, which talks about how ARC can be used in the L1, L2 space and where Tashi, the token, participates in all of that. So anyway, so lots of cool stuff happening in the white paper, including design philosophy. But I figured it'd be useful to take a few minutes to kind of go through and talk through the on a whiteboard, on Excalibur whiteboard, how these pieces fit together. Because it's one thing to read it, and it's another thing to kind of like look at it and see it in action. Okay, now let's come back into... I want to talk about the next thing here, and let me go back into Discord, and we're going to stop the sharing because we're not talking about that anymore. Okay, so we're still live. Okay, cool, cool, cool. The next thing I want to talk about is something we've been working on, which is a new CLI tool. Um, I, I'm just going to be really brief about this. The new CLI tool is an improvement on what we've built before. So what we built before was kind of a bash script, a command line script that wrapped Docker, and it helped you kind of set up Docker and run things. But there's kind of two breaking points there. One of them is if you're not on the right operating system and don't have the right configuration, the bash script may not work the way that you want it to work. And the other part is Docker. Like you have to have Docker set up and permissions have to be set up for Docker. So there's some challenges, right? There are two spots for major challenges. The script being compatible with your operating system and setup, and Docker being installed and configured correctly. We're kind of going a little bit different direction now where we are taking the core node software, which by the way is running inside Docker. Like the core node software is running in Docker. We just use Docker because it ensures like a consistent environment. But we're now building it to work on multiple operating systems, and we're going to build a CLI tool first that helps you manage your local node cluster on a specific device. And it's going to help you with things like ports. I know that's been a big challenge. But additionally, what it does is it now sets the stage for us to build a desktop installer, right? So if you have a CLI installer, it can run as an agent in the background. It becomes much easier to build a desktop installer that can use the CLI installer, interact with the CLI installer, and present a nice graphical user interface. So this is all coming very shortly. We're in the middle of working on the CLI side of it. And then the graphical interface is getting worked on right now as well, but that's probably not going to be ready, I'm going to say, until mid-January or maybe even late January. We'll have some announcements on the new CLI tool and the graphical user interface. But I'm going to give updates as I start getting updates. I'm going to share some screenshots about that, and we can walk through using it and stuff like that. Okay. Finally, sorry that going over the white paper part was a lot. So I appreciate you kind of sticking with me through that. But let's go ahead and go into the AMA section now. We've got just shy of 10 minutes. So I'm going to start off by looking at actually, no, let me go ahead and turn my camera back on. I know it looks weird because everything's backward on the camera, but at least you guys can see me now. So now let's go ahead and I'm just going to go through and look at some of the questions and see if there's anything that I can answer from the chat stream here. Let's see here. Lim, we got your ticket, so we'll be talking about that. Nults, we got to figure out the streaming thing. There's got to be something we can do at the lattice layer to help with that. Nults, always great, always having the use case and benefits for the users, companies that need the services, keeping them in mind. Savings in this size are a game changer. That's right. And that's really the fundamental driver is, if we have to invent a market, this is a very hard sell. If we have to go out and say, we think people will value our product and they're going to pay us millions of dollars. I mean, look right now where we are, even in DePIN, you've got products with real value, but you're kind of inventing a market. You're kind of going in and saying, we're going to do things in a new way. It's really hard. It's really, really hard. And some of the best projects are still in like the sub $20 million range in revenue. I mean, the top projects are still in that range. And so there's lots of opportunity for growth. You talk to any major like industry product, they're easily in the hundreds of millions, if not billions range, right? And so if we're still in kind of the sub 20 million range, there's lots of opportunity for growth. And so I think that's where some of the best things are going to be happening is, and for us specifically, we're looking at markets that already have spend and how can we optimize that? And the spend is so much that even getting a tiny fraction of it is a big successful company. So that's where we're kind of starting off. Crypto Hunter, what kind of updates are on the horizon in term of node development? Will there be a GUI? Yep. Or perhaps node version operating in Windows or Mac? Yep. Outside of WSL? Yes, sir. That's exactly what we're working on. For me, the current version is pretty easy to install, but for example, I have 20 referrals of which 15 just ended up registering and then leaving because they find it very difficult to install the CLI free node. I feel you there, Crypto Hunter. That's exactly right. And that's why we want to go. We're still going to do a CLI version first that is a native installer on Windows, Mac, and Linux. And so that native installer will be significantly easier to install than the current installer. So hopefully that gets easier. But then the next step after that is to add the graphical user interface, the GUI, on top of that. Yes, sir, Brian, it is going to be a ton easier. We'll extend the usage. Some people have trouble either in Docker or in general. You're right. Nults, you're spot on. Yep. So awesome. So those are all of my updates for the week. Any questions? I will take any questions. If you're on X, you can comment there. Let me see here. I do have chat open. So if you do comment there, I will try to see it. I'm going to hop into Telegram real quick. See if we got anything going on in Telegram that I need to address. Okay, Telegram is good. Let me go over to X and see if there's something there. Just want to make sure I look at all the places, answer any questions. Boom, 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 boom. Okay. Perfect. I think that's everything. So the stream is still going. Any questions at all, feel free to ask. And it's always my pleasure to try to explain as best I can. So if there are any questions, first of all, I'm going to fix this streaming thing. I'm going to play with, I didn't realize the Discord is flipping the image. So I'm going to play with it. We'll figure out how to do this. I think I know how to solve this. So you might see me doing some test stages here over the next few hours, just trying to figure how to flip this screen so it works. But absolutely, if you guys ever want to participate in this, just join us in Discord. And then you can, if you want to join me on stage, if you got questions during the AMA session, I'm happy to bring people up on stage and answer those questions directly. And if there are any explainers you need me to do, I'm happy to also do that during these AMAs. I think during the community update, some of them, again, will be shorter. Some of them will be longer. Today was supposed to be shorter, but then I kind of got carried away with the whiteboard, and so it went a little bit longer. So I apologize for that, but hopefully it was useful and meaningful to you guys. So anyway, yeah, Brian, gotta love it when CTO has streaming problems. I think I'm doing okay here. Like we'll have YouTube up here, I think next week. We were supposed to have it up this last week, and there's some drama with credentials and stuff like that. Not a technical problem, but we'll have YouTube, X, and Telegram streaming, and then obviously Discord is where the action is happening. And it's just having multiple channels. So we've been doing okay so far. We're getting better every week. I'm adding some stuff on the video now too through OBS. So, but we're gonna we'll get into the swing of things here pretty quickly. We'll get into a cadence here and get it all dialed in. I think I know the answer to this, though. There's always some little weird thing that catches me off guard every week. So anyway, guys, thank you so much. Real quick, Crypto Hunter said, will there be an ambassador program for us to participate more in the project? I don't know that we're going to call it an ambassador program, but what you will see from the tokenomics, and you know what, maybe that should be next week's update, is we should go over the tokenomics section of the white paper. But we actually recently broke out a specific category in the tokenomic distribution model for ecosystem development. So that includes things like bringing in developers and bringing in resale partners, and so effectively building the demand side, right? So right now we're building the supply side. We've got a budget called the node budget, or the node category, that is going towards the supply side. We have an ecosystem partner budget now that is going to be going towards the demand side. So how do we create demand for these services that you guys are standing up? How do we make money for you guys? And I think both of those would fit somewhere around an ambassador program, where you're creating awareness and excitement about the project and the technology, and maybe even helping with some of the education and mobility and management of the people in the community as well. So I think in both of those categories, both the ecosystem development and on the node side, so supply and demand, there's room for something like an ambassador program to support that. So yeah, and I set up the ambassador program at Hedera back when I was there, and so that was a great effort and super valuable to us there. So all right, everyone, it is 11 o'clock my time. I'm going to do a little bit of research and figure out how to get this streaming thing to do its thing. And then I got to get back to work, guys. We got nodes to build. We got CLI tools to build. We got robotics demos to build. I got a white paper to publish. So much stuff to get ready. I hope everybody had a wonderful Thanksgiving and that you're having a wonderful season. We're about to head into Christmas here soon, so things will get festive. But we will be right here working hard the whole time. So anyway, thanks again, everybody. Cheers. Always a pleasure.